We're going to stay in Australia to discuss cancer and stress. I suspect we've all heard something about possible associations between the two. Well, research by Melbourne's Monash University appears to be clarifying what it is. This isn't yet proven. Trials are still taking place on humans. But Monash has found that stress drives metastasis, the spread of an existing cancer from the original tumour, in mice with breast cancer. Now, stress appears to add to the speed and spread of the cancer. It doesn't cause the cancer, but it helps distribute it. All of this is part of ongoing work, which Dr. Erica Sloan, who's leading the research team, told me about this afternoon.
So our research showed that stress helps cancer spread around the body. When a patient gets a diagnosis of cancer, often it's not, often they'll survive. But if they don't, then it's often because the cancer has spread and taken up residency in the lung or the brain. And so it's that process of spread that's particularly bad for patients. And it's the process of spread that's very sensitive to stress.
Right.
And so one of the things that we've done is identified drugs that are out there that are being used already for other purposes, and identified how they might be used in combination with existing treatments to reduce stress levels in patients and so allow things like chemotherapy to work better.
So give us an example. So this is quite separate from treating the cancer. This is treating the stress, right? So what are you using to do that?
Yeah. Right. So there's class of drugs called beta blockers, which have been around for 3-4 decades. They're used to lower blood pressure, and also things like anti-inflammatory drugs, so aspirin, for example, by reducing the neural signaling. So beta blockers reduce, when you have a lot of adrenaline in your body, when you're very stressed, beta blockers stop the cells in your body from hearing the adrenaline.
So the cancer is transmitted like adrenaline, and the whole point, I guess, of adrenaline is very high-speed transmission.
And this probably evolved as an adaptive mechanism. So you know that a bit of stress can be good for you. It can get you out of a threatening situation. The problem is that in a stressful situation a long time ago, you might have been gouged by a mammoth and then have a bacterial infection that you need to clear. Some of those same immune responses that would have been helpful in that scenario are not so helpful in the case of cancer. And so in this particular situation, what we're seeing is that the cancer is co-opting this process and growing new lymphatic vessels, changing the immune response in a way that then allows cancer cells to escape.
God, cancer's a sneaky bugger, isn't it?
It is, yes.
And so this is very exciting for people who have cancer, that in fact you can dull its ability to move around the body and the speed with which it does it by using things as simple as beta blockers and aspirin.
That's what we're looking at, and that's certainly what the research indicates in mice. We can certainly stop it, and in patients we would never use these. We would never treat cancer with just aspirin or with just a beta blocker. But the idea that we might be able to use it in combination with existing treatments to improve their efficacy. And so at the moment we have a clinical study that's ongoing at Peter Mac at the Cancer Centre here in Melbourne, where patients come in and they've just been diagnosed with breast cancer, and we give them the opportunity to take part in a study where they're randomised to receive either a beta blocker or a placebo. And we're looking at what that does both to their well-being, to their levels of anxiety, but also to genetic signatures that would indicate that perhaps the cancer won't spread as much.
And are you seeing the results from that study yet? Is it too early to say what it's telling you?
Right, so I'd love to be able to, it's too early to say now. So it's a double-blinded study, so we don't know either who receives what. But stay tuned. Later this year, early next year, hopefully we should have some results out from that.